Hello and welcome to my third attempt. I've deleted the first two of making this RNA Seq protocol screencast in this familiar lab environment. Because if you thought the Wi-Fi on campus was terrible, you should see the Wi-Fi at my house. So I am going to be screen sharing. I haven't figured out how to screen share multiple applications, so I have to screen share them separately. Hold on. Between the browser window that I'm using and my terminal window, because I cannot show them both or it goes into this infinity screen that looks a little something like this. Let's see here. So if I wanted to do my entire screen, it's pretty scary. So I'm going to screen share. That's not what I wanted. Individual applications, starting with my terminal window that I'm working in. So basically, I have already completed this protocol up to the point where I need to do analysis with the GFF compare in R because I'm having difficulty installing some of the R packages. With the version of R that I have, it's giving me errors regarding DevTools. And so I was just waiting until you got back to get some help with that. But in terms of the rest of the protocol, I have completed it. But for the purpose of this demonstration, I have created a new directory that doesn't have any of the files in it, and I've also deleted the HiSat, SAMTool, StringTie, so I can show how they can be downloaded in order to use them. And yeah, so we're just going to go ahead and get started. We will change into the directory that I've made for this assignment. You can see it's an empty directory. So the first thing that you would want to do is get the X chromosome data for this assignment. This might take a second, but it definitely won't take as long as it was taking at home. When I did this protocol the first time, I was practicing it on my desktop, and it went a lot faster than trying to use wireless connection, but fingers crossed that it will just work with this. So Okay, so it's almost done unpacking. Yay, went way faster than. Okay, so what you'll need to do is, oh, gotta get back over here. Great, so if you see now we have the Chromosome X data directory. Oh, I don't know why that, I do not like that. Oh, I forgot. Sorry, it's late. I'm tired. Okay. So we can inspect the contents. So you've got the indices and all of the samples. So if we look at all the samples, the FASTQ files are all gzipped, and there should be 2 FASTQ files for every sample, 1 for each read. These are, I believe, these are paired end samples. So, okay. So the first thing that we are going to want to do is to download all of the software programs that we're going to need to complete this analysis. So we are going to so I'm going to show you how to download HiSat2, SAMTools, and StringHi. So yeah, let's get started. So first you're going to want to go to the browser. So I'm going to switch the, oh, it's me again. I'm going to switch the application window to the browser that I'm sharing with you. So okay. So the HiSat, we need it to be the version 2.1.0. So we want this release. So all we have to do is get the source code downloaded. And now I'm going to go ahead and show how to get all of the source codes that we need. So when I go back to my terminal, we can just stay there since I can't do a full screencast. So SAMTools net. So with SAMTools, I have been So the current releases, I was having a problem with the 1.9 release. It had an error message. It has a fatal error every time I was trying to download it. So I just downloaded an older version that was still compatible with the protocol, version 1.19, which is, I don't remember where I got it from. GitHub project page, manual page, source code releases. This was it. So I downloaded version 1.19. Like I said, the most recent version is 1.9, but I just kept getting a fatal error message and I didn't want to have to deal with it. So this version is also compatible with the protocol. You just have to add in an extra line in your script, which I will go over when we get there. So if you check, we've got, okay, cool. So now the last thing that we'll need will be string tie. So I'm going to go there. And for string tie, we're going to be getting the 1.2.2 version. So obtaining and installing string tie, let's get the, oh, where, 1.2.2 release. Okay, why is it? I think this is, yeah, this is good. Okay, so let's try switching back to the terminal window for my screen share. Okay, so now if we go into my downloads, we should see these 3 things that we've downloaded. So now all I want to do is, oh, there is an important step that I have skipped is before we start copying any of these programs, I want to export my path so that we can execute these programs in any directory that we are working in. So in my home directory, you can see that I have a directory called bin. So I just want to, I've already made that. I just want to export we're going to go back in the downloads and we're going to copy into my great. And just to confirm that this download was successful, we just have to type the command HiSat2 and you see all of the options that come up. So this shows that, where does it start? where were we? Yes, it shows all the usage options for HiSat2. So that we have this software downloaded. So now let's go back to my downloads, and we need to finish unpacking the SAM tools, JX, VF, SAM tools. Great. So now, okay. Oh, that's because I didn't. Not mail. Okay, had a couple errors, but I think it's still going to be okay. I want to copy, that's not copy. Let's go into this directory. I don't know why it says SAM Tools 21. But let's give it a shot. Into my, okay. So now we're going to verify that we have this downloaded as well. And we're going to go back into downloads and finish unpacking string tie. Okay. So we're going to copy Oh, I just want to specify that we just want this. Great. Okay, so now we've got HiSat, SAM tools, and string tie all downloaded and in my bin, so we can go back to the directory that we're going to be doing the work in, and I have also been able to, if you see, I've got Miniconda on my laptop, and I was able to download HiSat without any problems and string tie without any problems, but I was having difficulty with the SAM tools download from Conda. It wouldn't run once I had completed the download and tried typing in SAM tools to verify that it was downloaded. And just because I wanted everything to be the same steps for the screencast tutorial, I was just going to use the go to the browser and download the source code method for downloading all of the software, so it would all be uniform. But Conda, if I was able to get it to work, is very fast and easy to use too. So I'm just going to clear my screen so it looks good. Okay, so here we've got the Chromosome X data downloaded, and now it should be a very fast I just realized another thing that I'm probably going to want to do is move the bash scripts that I wrote into the directory, so I don't have to. I could also just call them, but this is weird. Okay, so I'm going to go to the in this directory, I have a couple of scripts for pipelines that I want to move over. So let's start with my HiSat one. We will move it to I'm going to move my SAM tools pipeline to so now I have all my scripts that I need, and we can take a look at these scripts, and basically it just has all of the samples that we're going to be running, defines read 1 and read 2, and runs HiSat with the options that are given in the protocol -P8. And also specifies the output of the SAM file for each sample. So let's just gonna run this in the background. But actually, first I want to make sure that I changed the location. I have to go in and change the location of these files because I am now going to be doing this in, so I'm going to do this really quick in my text editor that I use just to change the directory from HiSat practice, which was where I did the first, to RNA Seq Protocol is the name of the directory that we're working in now. I also want to make sure that not only do I change the directory for the reads, but I also change the directory for the index so it knows where to find it. Okay. I also can probably go ahead and make sure that all of my scripts are okay in samples. These will be fine. I think that we should be good now. Hopefully no errors. Oh, did I put a space? So, this should be good. I ran it in the background when I was doing this the first time, so I could work on other things, but let's see. Let's check on it. So yeah, you can see that it's getting through making some of these SAM files, so when it's done. But yeah, I'm just gonna hang out until then. Okay, so I just manually counted them, and there are 12 SAM files, so it made it through all the way. So now we can okay. So now all the reads are aligned, and we can convert the SAM files to BAM files using, here I will show this bash script. So this is the extra line that is required if you're using SAMtools version 1.19 instead of 1.9, the most recent version. You have to first convert the SAM files to binary BAM files before you can do the SAMtools sort with the options that are specified in the protocol. So, and then after you run this script, you have the option to remove all these ones that are these files you've generated called unsorted BAM. So just gonna run that for a while. Protocol says that this part takes about, what is it? It doesn't say, but it was pretty fast. Just a few minutes. Let's take a look. Okay, so I have my first unsorted BAM. So this will just probably be less than 10 minutes. So Okay, so I believe it is all done now. So we might want to delete all the temporary files. You can just do this using a wildcard. I'm just going to delete the unsorted BAM files, actually. So now I have my SAM and BAM files for everything, and I can go ahead and so I want to assemble transcripts for each of the samples from the BAM files, and I can use string tie script that I wrote to do this. So we can take a look. So for each sample, we're just going to run string tie with the options -P8-G. And let's see here. Let's see if we can expand this to show everything. So this is the script that I run. And then just have this log file and let it run. So this is pretty fast. And so we can now see we have our GTF files for every sample. And the last thing that we need to do is just have this merged transcript from all of the samples. And in order to do that, did I write that into this other script, or let's see here. No. No, this is for ball gown, which I changed it to the RNA Seq directory. Okay, so first, in order to even get to the part where we estimate transcript abundances and create table counts that will be used in ball gown, first we have to merge all the transcripts that we have created, and that's just a command. Okay. So at this point, we can run my last script that I wrote. We just took a look at. We can go back and take a look at it again to create the table counts for ball gown and estimate transcript abundances. So it's also optional in the protocol to compare the transcripts to a reference annotation using GFF compare, but I'm not going to put this in this video until I figure out how to download all the packages that I need with the version of RStudio that I have. So let's just go. Okay. Okay, so that is everything that needs to be done before we can go on to run the differential expression analysis using the R packages. And we can also take a look. So you see here in the directory, we have all of the SAM files, BAM files, and gene transfer format files. Another option that we can do is to take the BAM files and generate them into .bai files so that we can look at these reads in a genomics viewer like IGV, like we did in class. But now we can go ahead and take a look into this ball gown directory that was created from the last script that we ran and see that we have all of these count tables ready in this directory. So that is all of the steps I'm going to put in this video. And once I get the R part figured out, I will have that in the next video. So